algebra kids. I am going to go over a few problems from our inequalities review worksheet for you. I'm going to go over the ones that I think were the tougher problems on the review sheet. I'm going to start with this multi-step problem that was on the second page. Negative 5r plus 15 is greater than or equal to negative 5 times parentheses r minus 2. In this problem, we're going to have to distribute. We're going to have to move all the variables onto one side. We're going to have to combine like terms. We're going to have to graph it. This problem has it all. So let's begin. The first thing I want to do is to get rid of these parentheses by distributing. I'm going to need to take the negative 5 and give it to the r. That will be negative 5r. Write down the minus sign. Then give the negative 5 to the 2. Negative 5 times 2 is negative 10. And I know what you all are thinking. Minus a negative does, in fact, make a plus sign. Then we write down the rest of the problem. The original problem started with negative 5r plus 15 is greater than or equal to all this stuff. Now we have to get the r's to be all on one side of the equation. And it doesn't matter which side you choose. I'm going to start over here, and I'm going to say I'm going to move these r's over to this side of the equation. So I have to do the opposite of negative 5r. Negative 5r is another way of saying minus 5r. So the opposite of minus 5r is going to be to add 5r to both sides. The 5r's cross off. I have 10 left on the right is greater than or equal to, oh my goodness, on the left, when we combine these like terms, that makes 0. This minus 5r plus 5r makes 0, and this minus 5r plus 5r makes 0. So what I have left is simply 15 on the left and 10 on the right. And the sign in between them says greater than or equal to. Since there aren't any variables left, you just need to ask yourself, is this true? Is 15 greater than or equal to 10? Yes, 15 is greater than 10. So this statement is true, and it's always true no matter what x is, or oh, I'm sorry, r, no matter what r is. You can put any number in the universe right here where r is. And when you go to solve this, you end up with 15 is greater than 10, which is a true statement. So every number, every real number that you know is a solution to this inequality up here. So the answer to this is all real numbers. This is the abbreviation for real numbers. All real numbers, or you can write it out, all real numbers. When we graph the answer for this one, when you have to graph all real numbers, you just put a line over your number line and your big arrows pointing in both directions. Every single number on this number line, these ones close to 0 all the way to positive infinity, these numbers close to 0 all the way to negative infinity. They are all answers to this inequality. By the way, if you're solving an inequality like this and you get an answer that's not true, for example, if you would have gotten, maybe let's just pretend there was a 9 here. If you would have gotten 9 is greater than or equal to 10. That's a false statement. So your answer would be, there is no answer. You would write, this symbol means there is no answer. Or you can write those words out if you want to. So if you get a false statement when you're solving an inequality, the answer is there is no answer. If you get a true statement like we did, the answer is all real numbers. Let's do another problem together. Let me see. Let's do, on that same page at the bottom where it says the compound and problem. We're going to do the compound and problem, where it says 5 is less than k minus 2 is less than 11. If we have to solve this inequality, Since it's one long inequality instead of two separate ones, we have to split it into two parts. So we have to split this side into 5 is less than k minus 2. You take the two things on the left. 5 is less than k minus 2, and that's one inequality. Then you take the two things on the right and make those another inequality. K minus 2 is less than 11. So you take this one long inequality and split it into two. The middle part goes on both sections. The left goes on the left, the right goes on the right. And now we solve these two inequalities. Here's k, they're subtracting 2, so I would add 2 to both sides of this inequality. I get 7 is less than k. And when you get an inequality that has the variable on the right, you flip it. You put k on the left, 7 on the right, and switch the sign. For this inequality, they are subtracting 2, so I have to add 2. I get k is less than 13. And I don't need to flip anything. K is already on the left-hand side. So my answer to this inequality is k is greater than 7 and k is less than 13. When you have one of these long inequalities with 3 parts, that is an and problem. And we'll go ahead and graph this. We need to put 7 and 13 both on the graph. So here's 6, here's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I just put a couple numbers around 7 and 13. Open circle on 7. We need all the numbers bigger than 7, so the line will be going this way. And it's going to stop at 13 because we need all the numbers less than 13. Open circle on 13. This is one of those problems where there are 2 circles and you highlight all the numbers in the middle. That is that problem. Turn to the last page. We're going to do the last 2 on the last page, the absolute value inequalities. We're going to do these especially for the people who weren't here on Friday. The absolute value inequalities. You have absolute value of x plus 3 is less than 10. When you have an absolute value inequality, you need to think that whatever is in here, whatever is inside these parentheses, not parentheses, absolute value, whatever is inside this absolute value has to be less than 10. So whatever this value is needs to be less than 10. So we could have a 10 in here, or we could have a negative 10 in here. The absolute value of 10 is 10. The absolute value of negative 10 is 10. So we would split this inequality into 2 parts. We write exactly what's on the inside, x plus 3, and put is less than 10, because whatever's in here could be less than 10. Or we write down x plus 3. On the other side of the inequality, we write the negative. We write the opposite of the number, and we flip the sign. We make this greater than. So when you have an absolute value inequality, you write exactly what you see without absolute value lines. Then you write exactly what you see on the left without the absolute value sign. Flip the inequality, make that number negative. If you don't understand why, I'm afraid I can't teach you on the video because it would be way too long and you wouldn't watch it. It's just something you're going to have to remember. Now we can solve these 2 inequalities. We will have to subtract 3 from all 4 sides to get our answer. We end up with x is less than 7. And over here, the 3's cross off. We have x is greater than negative 13. One thing that we learned in class on Friday was if the original absolute value had a less than sign, then it is an and problem. So this will be an and problem where we're going to have two dots and everything in between. If the original problem has a greater than sign, then it's an or problem where we have two circles and everything on opposite sides. Let's graph this. We need to go from negative 13 to 7. How about if we count by 5? Here's negative 15, negative 10, negative 5, 0, 5, 10. We need an open circle at 7. 7 is right about here. Open circle. All the numbers less than 7 are going to go this way. And then x is greater than negative 13. Here's negative 13. Open circle. All the numbers bigger than negative 13 go this way. So my line is going to be two circles with everything in between. At the bottom of this one, I also asked you to write it in interval notation, I think. No, I didn't, but let's do that anyway just to practice interval notation. This line starts at negative 13, and it's a parenthesis because that's an open circle, and the line goes to 7, and we put a parenthesis because it's an open circle. Last one. Let's do this last one. We have negative 1. Absolute value, c plus 4, end of absolute value, is less than or equal to negative 3.6. Now this problem has something outside of the absolute value, so we have to get rid of that before we split this problem into two. We're going to have to divide by negative 1 because the absolute value is being multiplied by negative 1. I'm going to need to divide by a negative 1. So negative 1's cross off. I have c plus 4 is, let's see, and on this side, negative 3.6 divided by negative 1 is 3.6. And since I divided both sides of an inequality by a negative number, I have to flip the sign. I need to make it greater than or equal to. Now, since I have an absolute value, I need to split this problem into two. Whenever you have an absolute value, you're going to split the problem into two. You're going to write down exactly what you see. C plus 4 is greater than or equal to 3.6. And write down what's on the left. C plus 4, flip the sign, make it less than or equal to, and make this number negative 3.6. Now we solve these two inequalities. They are adding 4, so I'm going to have to subtract 4 from all the sides. Subtract 4, subtract 4. The 4's cross off. I have C is greater than or equal to 3.6 minus 4 is negative 0.4. And in this inequality, the 4's cross off. We have C is less than or equal to negative 7.6. And now we can graph this. Let's see. By the way, in the last problem I told you when the original problem has a less than sign, it's an and. If it has a greater than sign, it's an or. When I say original problem, I mean this right here when you have nothing outside of the absolute value sign. So this is a greater than at that point. So this is an or problem. So my answer is C is greater than or equal to negative 0.4, or C is less than or equal to negative 7.6. So let's find negative 0.4. Here is 0. Here's negative 1. This is almost negative a half, so it would be right about here, negative 0.4. Close circle, and we need all the numbers bigger than that. That goes this direction. And then C is less than or equal to negative 7.6. So we need negative 7, negative 2, 3, 4, 5, 6. There's negative 7. Here's negative 8. Negative 7.6 would be a little bit more than halfway between those. Closed circle, that's negative 7.6. We need all the numbers less than negative 7.6. That is this direction. And that is our graph. All of these numbers will make this inequality true, and all of these numbers will make this inequality true. And that is our review for our test. If you have any others from the review worksheet that you don't understand that you want me to go over, make sure you ask about those tomorrow in class before we take our test. All right, you guys, good luck on your test tomorrow. Bye-bye.